Hi, this is Miss Delosier, and this is the last quad while I'm gone. It's on pedigree number 2, which is on earlobes, and I actually deleted the top part, so we're going to have to talk a little bit about it. We need to talk about free versus attached earlobes. So you can see the picture on the left is going to be attached earlobes, and then the picture on the right is what we call free earlobes. And we're trying to figure out whether or not this is a dominant or a recessive trait. So it's pretty obvious if you've done the first pedigree already. So we need to go ahead and we need to talk about what the shaded means. The shaded in this pedigree means attached earlobes. So if you're a shaded circle, you're an attached earlobe female, like the one on the left, and if you're a shaded square, you're an attached earlobe male. And so that one that is different in the bottom, again, third generation, we looked for one that's different from both of the parents and has a sibling that is different from itself. You'll notice that that shaded female, that is an attached earlobe female, but both of her parents had free earlobes. Now the only way for that to happen is if she is a homozygous recessive, little f, little f. Why do I say that she has to be attached as little f, little f? Well, if she has attached earlobes, and that's recessive, that means that free earlobes has to be dominant. So the parents are both going to be free earlobes, capital F, little f, capital F, little f. So I think if you Punnett square that out, you'll see, oh, free is dominant, capital F, attached is recessive, little f, and then she has to be homozygous recessive attached earlobes. That also means that her sister is going to have at least one copy of the free earlobe, but we don't know what the second copy is, and frankly, we don't really care, so we just put a blank there. All right, so we need to fill out the rest of this pedigree. We know everybody that's shaded is going to be homozygous recessive for free earlobes, so we can just go ahead and fill that in. So those are all going to be little f, little f. Now, I'm going to look at the rest of the pedigree and figure out who's what, predict who's what. So if I look at the first couple in the first generation, I have free earlobes and free earlobes, but I'm having children that have attached earlobes. So each of those parents, both the dad and the mom, are going to have a allele for the attached earlobes, which means they both have to have a little f, but they both have the capital F also. So those are both going to have to be heterozygotes, capital F, little f, and together that's how I'm getting those attached earlobe offspring, the little f, little f's. That first daughter, the sister of those three boys, could be capital F, capital F. She could also be capital F, little f. We don't know. It's just capital F blank, because whatever, we don't care. And then that just leaves that last parent, that last mom. So I know that mom married a dad that had attached earlobes. He's little f, little f. But I also know that they have a daughter that's little f, little f. Since mom is going to contribute 1/2 of her genes, dad is going to give a little f, but that means mom also has to give a little f. But she also has to have capital. She has to have the free earlobe allele because she has free earlobes, because that's what unshaded means here. So she's going to be free earlobes, but she's going to carry the allele for attached earlobes. And the mode of inheritance here would be autosomal, right? Because it's going to be on a regular chromosome, not the X or the Y. And we can see here that it's recessive. So the attached earlobes is going to be a recessive trait that is on a normal chromosome, not an X or a Y chromosome. So that's it for your quads for the week. I hope that helps, and I hope you kind of understand pedigrees. If you look in your genetics practice problems, it kind of gives you Punnett squares to work through those pedigrees. If you get confused on the ones that are the XY ones, I suggest you watch the videos on the bionerdery.